I spent much time here because it's going to apply to other types of relations. I remind you, this is a relation. It's talking about coordinates, x1, 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 meaning different values of x. The function calculates the y. Another x calculates that. Those are coordinates. There they are. This symbol here, let's write him in red because I think he's a dangerous symbol. He's a relational symbol. He's not a symbol that says calculate. He's not saying that. He says you are relating something with something. It's a relational symbol. He's not the only one who's a relational symbol. This guy is a relational symbol. Meaning we can read this as y is greater than or equals to this function. So because these are points on the line by this relation. Well, if I'm speaking about the y values, the function values that are either on the line or greater than the ones on the line, meaning I'm right on the line and I'm interested in everything above the line, because that's where I'm talking about the y, the points above the line. That's where you get the shading from. So you have to draw this line and shade it like this. Let's bring another relation, another ballpoint. Less or equals to. Well, we're interested in the points in the line because of this equality, like this one. But the y values, the other coordinates, must be the ones on the line because of the equality, and the ones less than the line. Less than the line. Meaning, for this relation, y is less or equals to this. A point here is a valid point, even if it's not a line. It's not on the line. Points on the line are valid. Now, what happens now when it's strict? Right? I'm doing it for both. Well, you have to draw the line, but a dashed line, meaning you are excluding the points on the line, because you excluded them. You removed the equal sign that was there. Meaning we can't even think of this. But the shading happens. Just follow the colors. So the strictly equals to, it's a solid line without shading. Now we're going to bring other functions. This is the simplest function to illustrate these concepts. These concepts hold for all functions. The key is drawing those functions, meaning graphing them. This is a graph. A line is a graph. It's telling us about these. It's a pictorial representation of all the coordinates of this relation. Let's go back to the equality. What I'm going to say also applies to the shading, but I'm going to remove the shading anyway. It applies to everything. So, do we need billions because there are billions and billions of points. This has got to be a solid line because that's what we said. Remember? So I'm going to use my hand now, which can betray me sometimes. But yeah, because of the equality. Meaning points on the line. And it's a solid line because there are billions billions and billions of coordinates on the line.